Hello guys, welcome back to my YouTube channel. And for today's video, I'm going to discuss to you about the OSI, the TCP or the IP models, and encapsulation and decapsulation, and the ARP process. So my name is Dharyll from Bat State U, and without further ado, let's get started in explaining this topic. So first thing that we're going to discuss is the TCP or uh, here first the OSI or the Open System Interconnections. So the Open System Interconnection model or the OSI model is a conceptual model that characterizes and standardizes the communication in functions of a telecommunication or computing system without regard to its underlying internal structure and technology. It also model was created by the International Organization for Standardization or the ISO, and an international standard setting body. So it was designed to be a reference model for describing the functions of communication system. So the OSI model provides a framework for creating and implementing network standards and devices, and describes on how network application on different computers can communicate through the network media. So of course, in the OSI model, we have 7 layers, which is in the layer 1, it is the physical, layer 2, the data link, layer 3, the network, layer 4 is the transport, layer 5 is the session, in the layer 6, it's presentation, and layer 7 is application. So first I'm going to discuss to you one of these layers. First is in the layer 1, which is physical. It's defines on how to move bits from one devices to another. So it details how cables or connectors and the network interface cards are supposed to work, and how to send and receive bits. So that is all about the physical layer, and the next is the data link layer. So in the data link layer, it encapsulates a packet in a frame. So a frame contains a header and a trailer that enable devices to communicate. And the header most commonly contains a source and destination MAC address. So trailer contains the frame check sequence field, which is used to detect the transmission error. So the data link layer has two sublayers, which is the logical link control and the media access control. So the logical link control used for the flow of the control and error detection, and the media access control is used for the hardware addressing and for the controlling the access method. So next layer I'm going to discuss is the network layer. In the network layer, it defines the device addressing on routing and the path determination. So device addressing is used to identify a host on a network. So example is by its IP address. The next layer is the transport layer. So in the transport layer, segments big chunks of data received from the upper layer protocol. So it's establishes and terminates the connections between the two computers, so used for flow control and data recovery. And next layer is the session layer. So session layers defines on how to establish and uh, terminate the session between the two systems. So in the next layer is the presentation. Yes, the presentation, and in presentation that it defines the data formats, and some compressions and encryptions are defined at this layer. So in the last layer is the application layer. So this layer is the closest to the user. So it enables the application to communicate with the other network applications. So that is the all about in the OSI system interconnections. So next thing that we're going to discuss is the TCP and the IP models. So the TCP or the IP models was created in the 1970s by the Defense Advanced Research Project Agency, or the DARPA. So as an open vendors a neutral public network model. So just like the OSI model, it described the general guidelines for designing and implementing the computer protocol. So it consists of four layers, which is the network access, the internet, and the transport in the application. So the TCP or the IP model has a fewer layers than the OSI model. So the application, the presentation, and the session layers of the OSI models are merged into a single layer in the TCP/IP model. So also in the physical and the data link layers are called the network access layer in the TCP/IP model, and the layers here is the link, internet, the transport in the application. So the link layer defines the protocols and hardware required to deliver data across from a physical network. So in the internet, so it defines the protocols for the logical transmissions of packets over the network. In the transport layers, so it defines the protocols for setting up the level of transmission service for application. So this layer is responsible for reliable transmission of data and the error-free delivery of packets. So the last layer is the applications, which defines protocols for node-to-node applications, communication, and services to the application software running on the computer. So that is all about in the TCP/IP models. So next topic that we're going to discuss is the encapsulation and the decapsulation. So first, let's discuss about the encapsulation. So encapsulation happens when the data moves from the upper layer to the lower level of the TCP/IP protocol stack. So each layers includes a bundle of relevant information called the header, along with the actual data. So the data package containing the header and the data from the upper layer then becomes the data that is or package at the next lower level with the lower layers header. So the header is the supplemental data placed on at the beginning of the block of the data when it is transmitted. So the supplemental data is used in the receiving side to extract the data from the encapsulated data packet. So this packing of data at each layer is known as the data encapsulation. So next topic that we're going to discuss is the decapsulation. So in the decapsulation, it is the reverse process of the encapsulations or the encapsulation. It occurs when the data is is received on the destination computer as the data moves up from the lower layer to the upper layer of the TCP/IP protocol stack. Uh, what happens is each layer unpacks the corresponding header and the uses of the information contained in the header to deliver the packet to exact network applications waiting for the data. So we are done in the explaining the encapsulation and the decapsulation process. The last topic that I'm going to discuss is the ARP process. So in the ARP process, also known as the Address Resolution Protocol, so it is a procedure of or for mapping a dynamic internet protocol address in IP address. So two permanent physical machines addresses in a local area network LAN. So the physical machine address is also known as the media access control or the MAC address. And the address resolution protocols features performs a required function in the IP routing. So the ARP finds the hardware address, also known as the media access control, uh, of a host from its known IP address, and the ARP maintains a cache of in which a MAC addresses are mapped to IP addresses. So the address resolution protocol was developed to enable to communications on the internet network and is defined by the RFC 826. So the layer 3 devices need an ARP process to needs an ARP to map the IP network address to MAC hardware address so that the IP package can be sent up across the network. So before a device sent to its datagram to another device, it looks at its ARP key to see if there is a MAC address and corresponding IP address for the destination device. So if there is no entry, the source device sends a broadcast message for every device on the network. So each device compares the IP address on to its own. Only the device which the matching IP address replies to the sending device with packets containing the MAC address for the device. So the source device adds the destination MAC address to its ARP table. So to future reference, create a data link header and the trailer that encapsulates the data and then proceeds to transfer the data. So that is for the ARP process, also known as the Address Resolution Protocol. So that's it for today's video. So I already discussed you the OSI model, the TCP/IP model, encapsulation and decapsulation process, and the ARP process. So if you like this video and if you learned something, please leave a like and share and subscribe to my channel. Thank you for watching. Bye bye.